Today we are going to introduce to introduction to machine learning. Okay. At the second part of this lesson, we will write the Python code to build the linear regression, classification, and multi-layer regression problems. Okay. And so, first of all, what is the ML? Machine learning. Machine learning is a subfield of artificial intelligence, guys. Okay, and so this mainly focusing on development of algorithm and models. Okay, which we are using to classify or regress any data coming from the measurements. Okay, and also it enables computer to learn from data. Okay, and so, but what's our purpose, or to do what? The main purpose is that prediction. In terms of the regression or classification, it doesn't matter, or the what, we will make the decision. Okay. These two of them are accomplished by using the multi-layer or machine learning algorithms. Okay, and so we can summarize all the terms in here just like this one. The main purpose of the machine learning is that it can automatically, this is important, automatically improve its or their performance for a specific task without being explicitly programmed. Okay, normally we should program the whole task for the mathematical algorithms, but in the machine learning algorithms we cannot, or we do not do that, because the machine learning can learn any data or the proposition or the distribution by using the machine learning algorithms. Okay, any question? There is no question, and so we need to write the types of the machine learning algorithms. Okay, first of all, we have the 5 kinds of ML, such as, first of all, we have the supervised learning. In this learning technique, we learn labeled data, which means that we assign the sum process to the 1 or 0, and we have already this data, and so this data is fed into the machine learning algorithms, and so we can improve or learn this kind of labeled data in order to decide or predict any conditions. Okay, and also we have the unsupervised learning, which means that we can learn this unsupervised feature from the unlabeled data. For example, if we have any data distribution x1 and x2, and so if we have the many data in here and also in here, and so we can deduce that this is the one class, this is the another class, but we don't know any label information about it. But we can see that this data is distributed around some points in here, and another one is around in here, distributed. Okay? And also, we can learn the data distribution as the semi-supervised. This is the what from both labeled and plus unlabeled. Okay? And also we have another learning method, which we call it the reinforcement learning. In the ML problems, we can learn the any data using what the agent based reward maximization. Okay? Our ML algorithm decides the some prediction, for example 1 or 0. We can assign it, and so this agent produces it. And so we critique to this conclusion based on the what, the reward or the punishment. And so we can improve our learning method based on this information. Okay? And also we have the deep learning algorithms in order to learn to our model or the data distributions. Okay? And so this is called the artificial neural network with multiple hidden layers. We will explain later these things, but this containing supervised plus unsupervised data. This two learning method is implemented on the what? On the deep learning algorithms, but we will look at the deeper, this kind of algorithms. In the first place, we will talk about the supervised learning. What is the supervised learning in math? Supervised learning is what the algorithms learns to make prediction or decision based on labeled data. But what's the meaning of this? In the supervised learning, we make the prediction decision based on the labeled data. Okay? And so, in order to understand this concept, we need to suppose that we have data distribution, just like this one. For example, we can draw this axis in here with the right angle. Okay? And so x, this is the feature, and y is the output. Okay? And also we can measure any data in here just like this one, and we want to build to the model to predict the whole data for a given the x values. How we can do that? We can build this kind of learning or the curvature line in here, and so this x value are the training data that we use to this data to learn the R distribution or the prediction values coming from this one. Okay? So if we have the x value and the y value at the same time, and so this is called the supervised learning. Okay? And so if we have a similar model just like this one, y is equal to the a x plus b. Okay? And so with the the xi to yi, then we can train model or the network. Okay? This is the supervised learning. And so, in general, we have two kinds of supervised learning. Either we can build the model to regress any data, just like this one, y and x. If we have this measurement data, and so we can predict the R model just like this one. And so this model is equals to what? To y is equals to ax plus b. Okay? This is the linear model. And so this is called the regression, guys. In the regression, we can utilize the perceptron or multi-layer perceptron or deep learning can be utilized to the what to build this kind of features. Or if we have any two input data, two features, x1 and x2, these are the features. Okay, these are also features, but this is the output. Okay, and so suppose that if we have the two data distribution just like this one, or we have some another data in here, just look at it. If we have the distributions, and so we can build the R model or learn coming from this data, because this is the, for example, it's the 1, this is the 0. This is called the classification. This discriminate the two classes in here based on this information. For example, the image classification or segment analysis or the sentiment analysis. We can classify the R input data in order to what? In order to generate the R output, which is showing to the what? To the R class type, 1 or 0, or class A or class B. Okay? Supervised learning are consisted of these two kind of learning methods. Either we can build the regression model or the classification model. Okay? Any question? Okay. So, in second place, we need to build the R model based on the what or learn R algorithm as the unsupervised learning. In the unsupervised learning, the algorithm learns a pattern or structure in data. Without being provided with explicit labels or target value. And the goal is to discover hidden patterns or relationship. Okay? So, how we can understand this property? Suppose that we have data like this one. If we have these two kind of input data or the feature, x2, this is the feature, x1, and this is the feature. For example, this could be the length, this could be the mass, okay, or weight. for a human. And also we can measure the R dataset just like this one, or just like this one. And so which data are in the class 1 or class 2? We don't know that, but we can see that we have the sun distribution in here, which is the closest to the another one in here. And also we have maybe another cluster or the distribution in here. And so our data can be classified even we don't know the label, just like this one. Maybe this is the cluster 1, maybe this is the cluster 2, but we don't know that. This is called the unsupervised learning. And so we can summarize that if the data is given as the x1 and x2, this is the unassigned or unlabeled data. And so the cluster gives us a similar pattern, which is given in here. Okay? In the supervised learning, we can use the denomination unlike the supervised one. Unsupervised learning learns the pattern or the structure, which is given as the distribution of the data. And so the mean and covariance or the standard deviation values are similar in that pattern, which means that in the class 1. And the class 2 has another of the different mean and standard deviation values in here. And this gives us the similar pattern in here. And so we have 3 main types. Of unsupervised learning. First of all, we have utilized this learning as to what, just like in the example, clustering C1 and C2. Clustering. In Turkish, kümeleme. For example, K-means clustering, or the GMM model, Gaussian mixture model, can be example of this kind of distributions. Or we can utilize this unsupervised learning for the for dimensionality reduction. Okay? For example, if we have this kind of data, and so our region of interest is given just like this one, but this is represented or distributed in the x1 and x2 just like this one. We don't have any vertical components in here. It does not exist, and so we can reduce the dimensionality in order to stabilize our learning algorithm based on this feature. For example, you can remove the noises from these x1 and x2 distributions in here. And so this is called the dimensionality reduction. Okay? And the principal component analysis is one of the best example for this kind of data. Okay? And also we had another algorithm to be learned using the unsupervised learning. For example, if we have any data distributions in here, just like this one, and so we have a similar pattern in here, right? But this one is the anomaly, which means that we can detect the anomaly using the unsupervised learning. Maybe the autoencoders or the variational autoencoders can be examples of this kind of learning technique. Okay? Any question? There is no question, and so we will continue with the semi-supervised learning. What is a semi-supervised learning? Semi-supervised learning is a combination of the unsupervised and the supervised learning, guys. Okay? And so the algorithm is trained on a dataset including labeled plus unlabeled data. So the goal is to leverage the limited data with unlabeled. Okay, so we can build a better model upon on the what the supervised or unsupervised learning. Okay, and so suppose that we have, for example, if we have the two data x1 and x2 in here, just like this one, and so for example we have this kind of feature. Okay, and so in this case for every x1 and x2 we don't have labels, but some does. For example, if we have the label of what the C1 or C2 or C3, but also we have the C, for example, or the 1 class can be given in here. Okay, and so in order to learn the semi or apply the semi-supervised learning, we can feed into the what the x1 and x2 into the unsupervised. Okay, learning to detect data or classes using, for example, the GMM, Gaussian mixture model, and we can build the C1, C2, C3, and also maybe this is the C4, but we don't know the meaning of the C1, C2, C3, C4. Okay, and after that we can feed this data into the what? Into the ANN, supervised learning with artificial neural network. And after that we can generate the y1, y2, y3, or blah blah blah. For example, y1, 2, y2 sinus this one, or cosinus this one, or 5. This is our output, but we don't know the classes of the C1, C2, C3, C4. These are the hidden variables. But we can apply the unsupervised learning to detect or the split the whole the data into the one class, and so after that we can utilize our training data just like this one. This is the 2, y1, sin theta, cos theta. This is assigned, but we don't know the C1, C2, C3, C4. This maybe improves our algorithm performance on the what? On our cases. If the data is not labeled, even if the C3 includes them, for example, we can predict it is C3 and C3 is equals to the Y3, maybe, in this case, okay? I will show the example of the utilization of these properties in the what? In the machine learning algorithms, okay? But we can utilize these two kind of algorithm based on the what? The unsupervised and supervised learning. And so we can combine it to what? To produce the better results or better building the model, okay? So this one is the R cases, and so we don't need to talk about the reinforcement learning and the deep learning because we will not explain these kind of algorithms right now for this lesson. Okay, guys? And so we have two special definitions: training and test dataset in machine learning. And so what is the meaning of this? In literature, the training data, the dataset to train ML model, okay? And this can be or may have labeled or unlabeled form, okay? This is called the training data. In order to train or to learn some properties coming from the measurements or the data and so on, this is called the training data. But what is the test data? Test data, this is the data set not to be used to train ML algorithm, okay? And so this is called the ground truth dataset, okay? Which means that this is the golden standard to the what to our algorithm is okay or not, or is the best of giving the results or not, okay? And so if we train the our ML algorithm based on the training data, we will test our algorithm or the trained machine learning model on the what? On the test data. And so we can say that our model is okay or not, okay? So but how we can split our training data or the test data in the ML algorithms when dealing with data splitting? We have, first of all, the holdout method. In the holdout method, randomly, we select the 70 or 80% training data for a complete one, and also 30 to 20% test data can be selected randomly, okay? And so if we put all the training data to train our ML algorithm, and so we will test this algorithm on the 30 or 20% test data. For example, if we have the 100 data, and so we can use the 70 data on the training, 30 data which is not trained for to the test data, okay? This is the one method. This is the common method to train our machine learning algorithms, okay? But we have another method, the cross-validation. Cross-validation method, more robust technique or we can explain it in which every data are divided into subsets, and each of subset is trained and tested. How we can do that? In order to train our algorithm, for example, we have 3 sections. For example, if we have the 30 data, 10, 10, 10 can be collected in here. 1, 2, 3. And so, in the first way, this is the test data, this is the train, and this is the train. Okay? After that, we train the neural network with the what? With the 1, 2, 3. This is the train. But this is the test right now, and so after that this is a train. Okay, and also in the last case we have the 1, 2, 3 subsets, and so the train, this is the train, and this is the test data. But how we can calculate the accuracy values of the R algorithm? We can collect or calculate each of the accuracy values for a given train and dataset, and so the total accuracy value is the mean values of these three accuracy values. Okay, if we select or divide the R dataset into the 5, and so this is equals to what? The 1 divided by 5, summation operator I is equals to the 1 to 5 accuracy I. Okay, this could be utilized to the what? To robust training datasets. Okay, any question? Okay, if there are no questions, and so in the ML algorithms we may have some techniques to improve our training process. There are important steps for data preparation for training or test to obtain the correct models. Okay, first of all, we apply the data processing fuss. It's necessary because we need to reduce the unwanted noises or meaningless data. For example, if we have any data in here, just like this one. For example, if we have these data sets, just like this one, this is the x1 and this is the x3, and so our model generates the meaningless data in here because it's the quite unorthodox, guys, and so we need to remove it. Also, we have the noises to break the robustness of our algorithm training class. Okay, and so we can model this algorithm just like this one, but we need to apply the data processing or some filters on this data set to stabilize our learning algorithms. Okay, after that, in order to increase our performance of the ML algorithms, we augment the data, increase the features, like, for example, if we have any picture, human picture, just like this one, we can train this picture in terms of the pixel values, RGB codes. But if we have this data, and so we can rotate this human just like this one. This is the same human, but it's rotated. Or we can rotate this human just like this one, and so we can feed these three input based on the one real one to our ML algorithms in order to augment our data sets. Okay, so data augmentation is another important properties for our training or the ML algorithm learning process. Okay, and also we need to balance the class. Just remember that we can select the whole data based on randomly or the cross-validation techniques, but this may be caused to the oversampling or undersampling, especially for the random selection. For example, if we have any data set in here, just like this one, this is the X and this is the Y, and so we can generate the sinus signal in here, just like this one. So in this case, maybe randomly just only this part is trained, but we have also this one. And so if we are using only this part, and so this is looks like to the what the linear signal with a what, with a tangent value of the 0, but the tendency or the tangent value is greater than 0 in here. And so we need to balance whole the class or the regression model in order to what, in order to provide the robustness in the training class. Okay, and so we can conclude that if the noise happens, and so it is oversampled because we have too much data in here, just like this one. Okay, or if we use, for example, this is the F2, this is the F1, and so if only F1 and F2 are used, we cannot model it because we have also F3 in here, just like this one. See? And so in order to train our algorithm, we can use this blue line, just like this one. We select each part as an equal part or equal number of random number should be utilized for the what, for G. G is the best selection for training the R ML algorithm. Okay, any question? So in the last place, we need to build the hyperparameter tuning. But what is the hyperparameter tuning? If the everything is okay or fine, but just remember this data distribution x and y. Okay, and also we have the some data in here. This looks like to the what, to the exponential graph or the function, right? And so this results of the what, like exponential graph, cannot be modeled based on to what, linear. If you are choosing the model, for example, y ax plus b, and so it gives us to what, to this kind of representation, the red one. This is the linear, and so we have too much error to drive this distribution of the data which is given in here, and so we need to use the exponential function in order to build the R cases. Okay, for example, y x y a times x minus b x, for example. This is the correct representation for the hyperparameter tuning for the what, for the selection of this y x pairs. Okay. Any question? If you don't have any question, and so we will continue with the regression model. What is the meaning of the regression? Regression is to what? To build the model in order to represent any curve or any signal in the what? In the ML or machine learning algorithms. Okay, and so suppose that we have these kind of features in here. For example, the length x and price y, 20, 25, and 100, for example. 100, 200, and also 300, which is given in here. And so we have the x to y representations in here. Okay, and also we can write it, the y is equals to the function of x. We know it, but we don't know the function of this one. Okay, and so in order to turn this length and price value, which is the input, which is the output, okay, and so we can draw this kind of graph, x and y, right? And also we can write this value maybe gives us to what, to this kind of representation. For example, this is the 20, and so this is the 100, maybe this is the 200, and also this is the 3000 maybe, and just go. Okay, and so if we have this information, and so we can regress this model based on this data set x and y. Okay, and therefore can write that we need to propose functional diagram to learn this data, guys. Okay. For example, if we have these propositions in here, and so first of all we have the model, which we call it the h, and also this h is fed with what, with the length value. Okay, and this generates the output of the price in here. Okay, and so in order to learn to the what, to this h, and so we need to apply the learning algorithm in here. Okay, in order to learn this algorithm, we need to fed the training dataset. Just like this one. Okay, and so this data set is coming from this one. Okay, and so in order to summarize this diagram, we need to propose to what, the appropriate model or function, which we call it to the h in here. Okay, and so also we must learn from dataset, and also we propose to the what, a learning rule, right? Otherwise we cannot learn it based on first derivative formation. We will talk about it. Okay, so in summary we can write it. We need to use the what, the model. We need to propose it. In the second place, we need to give the learning rule, and after that we need to create the energy function. Just remember the previous lesson. If we minimize this energy function, and so we can create our Euler-Lagrange dynamics, which is given in the nature. And so why we cannot use this property or the optimality conditions on the machine learning? We can use it freely because the nature does possess it. Okay. So how we can build these properties? First of all, we need to give the model selection. Okay, in the model selection, if the dataset are distributed like for example, in our cases y and x is equals to the what, in this one, and so this graph looks like the linear diagrams. Okay, this is the linear representation, and so we propose that the h is a function of x which is equals to some bias value theta 0 and theta 1 x, right? And so this model can emulate to the what, to the R measurement or the training data distributions. Okay, normally in the math, for an exact solution which is coming from to the what, to this one, x minus x1, x minus x2, blah blah blah, x minus xn is equals to the 0. N is the number of samples. This is the exact solution for this algorithm because the x1 is the first data, x2, x3, x4, x5, and so if you put the whole equation into the 1, x minus x1, and so this whole roots gives us the model, but this is so unstable. Maybe this diagram generates the what for this kind of representation, but at the training data, this gives us to the what, the exact value, but these parts are wrong for this model. Okay. And also think about it. What if we have these kind of propositions or the data distribution y and x? This is looks like to the what, to the exponential graph. Okay, and so in this case hx must be modeled with the what, the 1 minus exponential hx value, or hx value can be considered as 1 minus exponential theta 0 plus theta 1 x. Okay, and so for this data distribution we need to propose it. For this kind of data distribution we need to propose it, otherwise we cannot close or approach to the optimal solution for this machine learning algorithm. Okay. Any question? There's no question, and so we need to propose an energy function or the cost function in the literature, which we call it. Okay. In order to cost function or build it, in order to reach the proper model parameters theta 0 and theta 1, we need to define cost function like in the mathematical terms minimum value theta 0 star the exact values of the model theta 1 star j must gives us to the what, to the model. If we minimize this cost function, and so we can reach or the model to our training dataset in order to produce to our network correct. Okay, and so let's define to the what an error, like for example E is equals to the y training data minus hx. This must be going to the what, to the 0 in an ideal case, but for every training dataset, for example, if we have the what, the 100 numbers for a given 100 pairs for a x and y, and so each of them is going to do what, to the 0 at the error values, and so we can say that our model is trained. And so then we can write easily just like this one. J is the R cost function. This is equals to what, the 1 divided by 2, the summation operator 1 to the n e square must be equals to the what, the 1 divided by 2 summation operator 1 n is equals to y t y and h x I. Okay, and so if the h xi function is equal to the y training I, and then we can say the R training is done or complete. If this energy form is minimized just like the earlier Lagrange equation, and so we can build the R model itself. Okay, any question? There's no question. And then we will continue with what the sum features. In the cost function, just like this one, j is equals to 1 divided by 2 I1 and ei square. Okay, and first of all, 1 divided by 2 can be changed or removed in here. It's not necessary, but if we take the derivative of the j value, and so this 2 going to the head of this function, and so this 2 times 1 divided by 2 equals to the 1. This is simpler for for calculating the gradient values of this one. Okay, and also the cost function must always be differentiable, since we must reach first dynamic, because the R change which is given in the first dynamic. But in order to build this two feature must be completed. But how we can, or how to find the proper theta 0 and theta 1 in here, in mathematical modeling techniques. This is directly related to the learning rule derivation, guys. Okay, learning rule derivation. Okay, so if we have the model and cost function, we can create energy representation depending on what the theta 0 and theta 1 like. For example, if we have these two kind of representation, we have two coefficients, theta 0 and theta 1, which gives us to the our model parameters. And so this is theta 1 and this is theta 0. Okay, and also we can build the right angles in here just like this one, and we can create the energy function or the utilization. And also this is the j mean values. Okay, this j is equals to the 1 divided by 2 summation a square, right? And so we assume that if there a proper theta 0 star or theta 1 star in here, and so this gives us the j mean is equals to to the 0 or closest to the 0 or minimum values of this j value. But how we can do that? In the representation of this three-dimensional vector, we can convert it to 2-dimensional. This is the j value, and also we have the theta 0 and theta 1. If we look at the xy axis in here, and so this j function looks like this one, right? And so, for example, suppose that this point gives us 2.2. Theta 0 is equals to the 2, theta 0, theta 1 is equals to the 2. Okay? And so, also, maybe this is equals to for example, 5, 7. 5 is equals to theta 0, 7 is equals to theta 1. And so we can calculate it at every time to the cost function in here. But we need to reach these points in here. This is the j minimum value. Okay? But how we can do that? We need to change the theta 0 and theta 1 values in here, but based on the gradient values of these terms, right? And so, what is the gradient values of this j function in here? What is the value of this gradient in here? Dj, d theta, which is equals to the what, guys? Wait, yes, 0, right? And so, what is the gradient values of this term? Dj, d theta. which is smaller than 0. What is the gradient of this value, dj, d theta, greater than 0, right? And so, we can use the gradient values to what? To change the r, theta 0 and theta 1 value at each iteration in here. We need to update the theta 0 with what? The theta 0 minus d theta 0, right? And so if we can do that, if the theta 0 is given in here, which is smaller than 0, and so if we apply this theta 0 in the next case is increased, just like this one, and then increased, because this minus operator which is given in here, and this increase, this increase, this increase. After that, this turns or goes to the what? To the right hand side. And after that, in the right hand side, this dj divided by d theta, it's greater than 0. And so it turns into the what? To the this way, right? See, if we calculate the derivative values of these terms, and so we can update the r coefficients based on this information. But this could be, or maybe y minus 100. Maybe this is the 100. And so if we update these coefficients, 5 is updated to minus 9, minus 95. And the other term is the what? Minus 93. This is so huge. And so we need to multiply these values with the alpha. This is called the learning rate. It's generally between the 0 and 1. Okay? And also theta 1 is equal to theta 1 minus dj theta 1. This is called the what? The gradient descent algorithm. Algorithm for the what? For learning. Okay? In the Turkish, düşen eğim algorithms. Okay? So, we can train our neural network based on this information. And so we can use the gradient values to what? To find out the R form. Okay? And so in the algorithm, this is the last one. Okay? The algorithm is given by the linear regression can be given by while some j values is greater than epsilon. Epsilon is a small number. And so for I is 1, 1, and up to n, theta 0 minus alpha, dj, theta 0, theta 1 minus alpha, theta 1, and n. After that, we need to calculate the total j values in here, just like this one. 1, theta 0 minus theta x square, and therefore we can turn the whole algorithm. This is the learning algorithm for our cases. Okay? So choose the cost function and calculate the derivative values of these terms, and so we can calculate it properly. And so what is the hx is given in here, theta 0 plus theta 1 x, and so the dj theta 0, which is equals to 1 divided by 2n times 2, this is the derivative value, minus 1, theta 0 theta 1 x minus 1, and dj theta 1 is equals to 1 divided by 2n times 2 minus y theta 0 theta 1 x minus x. This is the R learning rule to what? First dynamics of the R algorithm based. Okay? And so for the multiple regression, I need 2 minutes, and after that we will break. Okay? Our topics is done. Multiple regression. This is the same, or we need to end up here, okay? Because the iftar is coming. Okay.